Hey, this is Mr. James. In this video, we'll be talking about how to perform transformations on a grid, including translations, reflections, and rotations. We'll do that using three different methods. First, we'll do each one using this right here, which is called transfer paper, also called parchment paper or patty paper. It's this see-through paper right here. In a few cases, we'll learn how to use this mirror right here to reflect things. And when we have none of those options, we'll also do these by hand without any tools. Let's start with translations. Let's start with number 1. They ask us to translate 4, -2. Now, if you're familiar with function notation, you'll also recognize that as P 4, -2. Now, what are they asking us to do there? Well, to translate is a slide. We're going to shift this original triangle, maybe left, right, up, or down a certain amount, to create our new image. Now, the first number here tells us how much we're going to shift in the x direction, right, which is left or right. And the second value here is how much we're going to shift in the y direction, or up and down. So first, I'll use my transfer paper. I've also switched to a pencil because it's easier to write on transfer paper with a pencil. Anyway, I'll start by tracing my original image called the pre-image and labeling the points Z, L, and P. And then remembering that the translation is going to be 4 in the x direction and -2 in the y direction. That means 4 to the right, 1, 2, 3, 4, and -2 in the y direction, or down 2, 1, 2. From there, I can go ahead and lift the transfer paper up slightly. I can see where my new points should be. My P is right here. Don't forget, these will be called Z prime, L prime, and P prime, indicating that they are the image after the translation. Connecting the points leaves me with my image right here. Well, what if you don't have that transfer paper with you? Well, you can still complete this translation using vectors. So I'll start with the point P and translate just the point P 4, -2. That is 4 to the right. 1, 2, 3, 4. Turn an arrow for that. And 2 down. 1, 2. So P now translates to P prime right here. And I can do the same thing with the other 2 points. 1, 2, 3, 4, 1, 2. So a vector, or this arrow here, translates Z to Z prime, and L, 1, 2, 3, 4, 1, 2. We'll translate L prime right here. Okay. At this point, I can just go ahead and connect my P prime, Z prime, and L prime to reveal my image after the translation. Again, notice how all of the vectors I used are all parallel, they're all in the same direction, and they're all the same exact length. They have this length of going over 4 and down 2, just like they told me in the directions. Now, number 2 is also translation. If you're familiar with function notation, this will be t -5 times 0. Now, just like before, I'll start by using the transfer paper. So I start by outlining my pre-image, labeling the points R, U, and Q. And then, let's see, translating -5, that means 5 to the left. 1, 2, 3, 4, 5. And 0 means I'm not going to move up or down in the y direction at all. So from here, I can just copy down those points. Okay, making sure to mark them with prime, Q prime, and U prime, and connecting those points to form my image, U prime, Q prime, and the R prime. Oops, excuse me, R prime. And again, you could do this simply with some vectors. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and there. 1, 2, 3, 4, 5, and there. And so, connecting those, we have our image, R prime, Q prime, U prime. Now for reflections, number 3, reflecting over the y-axis. Again, if you're familiar with function notation, this will be R y-axis with a lowercase r to represent reflections. So to do this first, the transfer paper, I'm going to mark what I'm reflecting over. This will use a marker. The y-axis is right here. Okay? So that when I take my transfer paper and add that layer on top, I'm going to trace not only the pre-image, of course labeling the points along the way, but I'm also going to trace the line of reflection. So when I go ahead and flip my transfer paper over, I can reline up the line of reflection and notice now where my image is. Just like before, I can lift up the paper and plot those points just like that. There's M prime, F prime, check that out. Yeah. Z prime, and Y prime. And that is a reflection with the transfer paper. Now, what if we don't have transfer paper? How can we do a reflection? We'll start by highlighting the line of reflection like I've done here in pink. Then we can remember the line of reflection is going to be exactly halfway in between the image and the pre-image. We call that a bisector. It's going to cut the image and the pre-image in half. So what we can do is, if we know that from F to the line of reflection is 2 units, we can continue on 2 more units, and there will be F prime. Similarly, if M is 1, 2, 3, 4, 5 units away from the line, then 1, 2, 3, 4, 5 more on the other side, and we'll have M prime. And you could use the same approach to find Z prime and to find Y prime. Right here, both same distance, equidistant from that line. Finally, you can connect your F prime, Z prime, Y prime, and M prime to get your image. There's a reflection. Now, in the beginning, I mentioned that we could use a mirror to do some of these. Now, you can only use a mirror to do reflections, and it's kind of difficult to use and not very accurate. So we're only going to use it once in this example here. Take your blue mirror and place it directly on your line of reflection, in this case, the y-axis. Okay? Like that. Then look to the side that your pre-image is on. You'll see not only your pre-image, but also the reflection as the image in the glass. What you've got to do is take your pencil, go to the other side of the mirror, and see if you can mark where that reflection is by looking in this side right here as you're going. So here's Y. Okay. Z would be right here. F. And here's M. Okay. So that, if you take the mirror away, you should be able to see markings where there should be. Finish up by labeling them: M prime, F prime, Z prime, and Y prime. Now, if you notice, there's 2 sets of markings here because I tried this once before and I was off by a little bit. See? So doing it this way is not as accurate as using the transfer paper or simply counting like we did before. But it's a nice trick you can use to visualize what's going on in a reflection and may help you a little bit. What about number 4, where they ask us to reflect over y equals 1? Well, the trick here is remembering that y equals 1 is not the same as the y-axis. Rather, y equals 1 is the horizontal line passing through y equals 1 on the y-axis. So here is my line of reflection, and that's really the hardest part here. After that, we're going to reflect either using transfer paper or by hand, the same as before. With transfer paper, you would take your paper, trace both the pre-image, marking the points, your line of reflection, flip it to create the reflection. Okay, copy those points down. Okay. What is that? My mistake. A prime is right here. We have S prime and C prime. And then we can connect those points to make our image. Note that C and C prime are in the same spot because C is on the line. In any reflection, any points that are on the line will not move after the reflection, and they're called fixed points. Or without the transfer paper, we would have our line right here. Again, that is y equals 1. We would just go ahead and count S is 1 unit away from that line of reflection, so S prime will be right here. A is 1, 2 units away. Let's do one more reflection here. Number 5, reflect over y equals x. Now again, in function notation, this is lowercase r, y equals x. Now the trick to this one, just like number 4, is knowing where the line y equals x is. Now remember that this could be written as y equals 1x plus 0, right? Reminding us that in the line y equals x, the y-intercept is 0 and the slope is 1, over 1, up 1. So in fact, the line y equals x is the diagonal line through the origin. I can draw that line in with a ruler or other straight edge. Once you've got that, it's not so bad. First, we'll do it again using transfer paper. Just like before, I will mark my pre-image, F, L, M, P, and my line of reflection. The only difference this time, instead of flipping up or sideways, we're going to flip diagonally, okay, diagonally, so that my line lines right back up, just like this. And look at that. Here's my image. Transferring that down. Okay, M prime, P prime, let's see, F prime right here, and L prime. Connecting those reveals my image. Now, if I didn't have transfer paper, I could still do this. Again, I start with one of the points, say M, and figure out how far it is to the line of reflection. The only difference here is that you're going to be counting diagonally. So it's kind of one diagonal unit to the line, so I'll have to go one diagonal unit on the other side to find M prime. For P, let's see, 1, 2, 1, 2. Remember, that line of reflection is a bisector. 1, 2, 3, 1, 2, 3. Means F prime will be right here. Another way to say that is that the line of reflection is equidistant from the image and pre-image. For L, 1, 2, 3, 1, 2, 3. L prime is there, and I connect my points to make my image. Oh, I forgot the prime on L. There it is. Now, while a mirror isn't the best for actually performing the reflections, it's not a bad idea to check your work using a mirror. If I take the blue mirror and place it on the line of reflection, just like I did number 3, I see not only the pre-image, but looking in the reflection here, I see where the image should be. If I look back and forth between the reflection and what I've actually drawn on this side, it seems like actually they look remarkably similar. That means I've done my reflection correctly. Another way to check to make sure that this is right is to turn it sideways a little bit so that your line of reflection is up and down, and to look on both sides and notice that, yeah, actually, these two sides do look like they're symmetrical and that they're reflected across this vertical line right there. Next, let's try number 6, a rotation. Rotate 90 degrees about the origin. Now, in function notation, this will be a capital R for rotation, and 90 degrees, and then the origin is 0, 0. That tells us the center we're going to be rotating around. To do this with transfer paper, start by, again, tracing your pre-image and labeling Y, A, and W. I'm also going to trace the X and Y axis, just like this. Okay? Now, it tells me that I need to rotate 90 degrees about the origin. Now, know that 90 degrees is a quarter turn, okay? And that whenever it doesn't give me a positive or negative, we assume this is positive 90 degrees, and positive 90 degrees is always in the counterclockwise direction. Okay? Now, what does that mean? Well, clockwise, the way a clock moves is this way. So counterclockwise will be in the opposite direction, or this way. Okay? And 1/4 turn means that if I start this shape here, okay, this triangle, when I rotate it, it should end up right about here. So putting the transfer paper back on, okay, I'm going to take my pen or pencil and place it at the origin, since that's the center that I'll be rotating around. I will then turn my transfer paper until it lines right back up, and that is a 90-degree or 1/4 turn in the positive or counterclockwise direction. Let me grab my pencil again and transfer that right onto here. W prime. Let's see. A prime was here. And if you notice, since Y is at the center, that is a fixed point. It's not going to move. And Y prime is in the same point as Y. Connecting my points reveals my image. Doing this without transfer paper is tricky, but it can be done. If we know that we're going to be rotating 90 degrees, which is 1/4 turn counterclockwise, then first off, I know that Y is going to be a fixed point since that is the center, the origin. So I first off know that Y prime is going to stay where it is. Next, I know since it is a 1/4 turn, anything on the negative Y-axis is going to end up on the positive X-axis, just like this. So since A is 2 units below Y, A must end up over here 2 units to the right of Y. So there's A prime. W is trickier to figure out where it's going to be. W, let's see, 3 units down, 4 units to the right. That must mean that after I rotate that, it's going to end up 3 units to the right and 1, 2, 3, 4 units up. And there's W prime. And I can connect my points as well. Doing this without transfer paper is tricky and sometimes can lead to mistakes. So it's good to check this one with transfer paper. Let's finish up by taking a look at the last 2 rotations. Number 7, rotate 180 degrees around the origin. Now in function notation, again, that would be capital R for rotate, 180 degrees, and then 0, 0, because that's the origin. Now, like we learned in number 6, if I don't tell you clockwise or counterclockwise, or say positive or negative, by default, that's 180 degrees counterclockwise. Counterclockwise. In addition, 180 degrees would be 2 90 degrees. So this isn't a 1/4 turn, this is going to be a 1/2 turn. Okay, so you're going to do this with transfer paper. Just like before, we'll start by tracing the pre-image, L, J, H, and labeling it L, J, and H. Also drawing the Y-axis and the X-axis. Okay. And placing our pencil or pen at the center of rotation, that's the origin, and moving it counterclockwise, that would be 90 degrees, but we're going for 180. So that's 180 degree, that's a 1/2 turn right there. And then we can label our image. That's going to be L prime. We've got H prime and J prime. Connecting those gives us our image. Now doing this without the transfer paper is much more difficult. You have to remember, since it's a 180 degree rotation, anything this quadrant here, this is quadrant 3, will be rotated up into quadrant 1 and vice versa. Okay? So H here will actually end up, it'll go from the bottom of this graph up to the top up here to create H prime. L will go from this side right here or up to here. Now this way, like I said, is much more difficult and requires you to visualize what's going on. Let's see, J is 2 away from both the negative X and negative Y axis. So when I rotate it, it'll end up being 2 away from the positive X and positive Y axis. So there's J prime. Then I connect the points to create my image. Now, if this is all confusing to you, please just go back and use the transfer paper. Lastly, let's end with number 8. Rotate negative 90 degrees about the origin. In function notation, this will be capital R, negative 90 degrees, and 0, 0 for the origin. Now this one is different than the last one because it has negative 90. Now if you recall, in number 6, we said that 90 degrees was a 1/4 turn counterclockwise because positive 90 degrees, or any positive rotation, is counterclockwise. the other hand, a negative rotation or a negative value for a degree means that we're going in the clockwise direction, right? So, negative is going clockwise. Now that's the way the clock moves, so it'll be in this direction here. Okay? This right here is clockwise. So one last time, let's grab our transfer paper and get this done. So trace my pre-image. We've got Q, M, and what is that? L. Okay. Trace the axes, X and Y. Put your pencil in the middle. And this time we're going to be moving in the clockwise direction, 90 degrees. There it is, 1/4 turn. And so I can draw my image, L, Q, and M. Of course, they're all prime since this is the image. And connecting them gives me this new triangle there. Now this can be done without transfer paper, but it requires some careful visualization. If you know we're rotating negative 90 degrees, which means a 1/4 turn in the clockwise direction, because negative, you know that anything on the positive y-axis is going to end up on the positive x-axis, right? It's a 1/4 turn. So M is at 2 on the y-axis. It will come down to 2 on the x-axis. Q is at 4 on the y-axis. So that will come down to 4 on the x-axis, Q prime. L is tricky. If L is right here, okay, the top of our graph, when we rotate it, it's going to end right out here, L prime. Okay. Connecting my points reveals my image here, M prime, Q prime, and L prime. Again, doing rotation without the transfer paper is tricky. One last thing before we wrap this up. Some people say, well, isn't there another way to write negative 90 degrees without using the negative symbol? And there is. If I take my transfer paper and place it back on to my pre-image here, remember, I could do a negative 90 degree rotation or a 90 degree rotation clockwise to get to my image. But on the other hand, I could go the other direction. I could go 90, 180, and 90 more will bring me to 270 degree rotation. So in fact, a negative 90 degree rotation is the same as a positive 270 degree rotation. Just something to think about while you're doing these rotations.